Uh, welcome to, I think we're on week 4 of the web APIs with our book club, but we are back in a new version of chapter 2. It's a new chapter. It did not, we didn't cover these topics before, but I think this is what I want to basically start the book with. So this will come after an introduction that talks about what APIs are and prerequisites and that kind of thing, and then it'll be this chapter. I think I like this better, and so see how this goes. All right, so again, I'd like you to kind of pretend this is the second meeting. Chapter 1 talked about what APIs are, and now we're going to do a chapter we haven't talked about hitherto yet. We're probably going to end up skipping that chapter when we get back to it next week, but we'll see. I haven't actually sorted that out yet. But yes, so the learning objectives for this new chapter are to learn to be able to read API docs, to fetch JSON formatted data from the web, and also to fetch YAML formatted data from the web. I have a typo there. To parse nested lists with the tidyverse, to use an API's open API specification, or technically definition, to learn about the API, and then to parse nested lists with Tiblify. And that's going to be kind of an introduction to that package. We'll be getting into it more in a later chapter. Something I'm curious about, if you could just say in the chat, whether you have worked with nested lists, the unnest and nest functions in tidyr, and whether you have ever seen the Tiblify package. I am guessing probably not on Tiblify, although it's deep into the tidyr docs they talk about it, but I'm just curious to see. I'm going to go ahead and go on. Yeah, okay, that's where I was suspecting, and it's totally fine if you've never worked with nested lists and not comfortable or not. All right. Before we get into nesting and unnesting, I'm going to talk a little bit about where to find APIs. So, we'll come back to that, Jim, because there are a million ways to do what we're going to talk about in this chapter, and I have to kind of choose one. Yeah, so for this, I am going to talk about this site, apis.guru, that we've talked about a few times before. They call themselves Wikipedia for web APIs. It is very likely, before I finish this book, that I'm going to make my own version of this type of thing. I've registered a URL and started sorting it out because apis.guru, it was down for a week or two. They haven't updated in a year. And it's supposed to be Wikipedia for web APIs, but you can't actually, you could edit it, but you'd submit a pull request and nothing would ever happen to it. And so I don't know, I want to make something that's a little bit more updated. But the principles will still hold, so I'm going to push forward with apis.guru until I change my mind, basically, until I get that worked out or find something else. So if anyone finds a free API directory, let me know. So, all right. We are going to spend a little bit of time browsing apis.guru to see kind of how you can use it, because it is still usable. There's apis.guru is this site that I'm hiding the browser bar, but this is just website apis.guru. When you come to the site, you land on this browse page. It says that you can filter the 2,529 APIs, and you can just search for things. So let's say you want to find an API that has weather data. You can search for weather, and it'll show ones that have weather in the name. apis.guru actually has their own API. We're going to come back to that in a second. But if you're trying to find YouTube, for example, they do have the YouTube data API, which is what Kevin and I have worked with in the YouTuber package. There's also 2 other YouTube APIs around like analytics and reporting. But the thing you have to be careful about when you are working with these, I'm going to show in the slide in a second, but it's good if you know what you're looking for. But even, I brought up the FEC API as an example, and it can be confusing because you search for FEC and you get deep art effects because it's got FEC in it. Fisheye Crucible, the URL in this has FE Crew, so FEC there. Perfect PDF has FEC in it, so it's just a really rough text search. And on the other hand, I can't easily pull one up, but like I know there are weather APIs that are in here that don't have the word weather in their name or their URL, so they don't come up in the search. So that kind of leads to, let me click these bullets real quick. You can grab the data from it directly. And so then we can use everything that we already may know, or that R is great at, to filter all that data and find what we're looking for. So before we do that, just for a moment, the APIs.guru does have its own API. From APIs.guru, we can load it up and hit docs. And actually, this tab's already open somewhere else. But we are going to, yes, I'm going to talk a little bit about this documentation. So this documentation that you can generate, you can load on APIs.guru for like any API that they have. It's using this program called Redoc. There's a commercial company called Redocly that this is the open source version basically. And it is a super easy way to make API documentation. So Postman also has APIs in it, but it has it's too open. Like it's user generated content. It is sometimes super wrong, and it's a little bit harder to work with under the hood. Like it's great to use it and test things out. And that's probably something I will talk about in a future version of this chapter, but it doesn't quite replace APIs.guru for me. I've been playing with it and trying to make it be a replacement, but it's like you'll have several copies of the same APIs, and it's a little bit harder to work with from that direction. All right, so, but this documentation, you will see either exactly like this or very similar to this for many APIs. The general format, there's this open source thing that generates the documents. There's a company that does the same style. And then there are other tools that generate almost the same documentation. So it's worthwhile to spend a little time digging in and kind of learning what to look for in these. In this particular case, it's telling us the name of the API and the version of the API. It's giving us the ability to download the definition of this API, which we'll talk about a lot more in a little bit. Give some contact information, a description, different things like that. And then it also, sorry, I need a drink of water. Has, like, below that are all the endpoints of the API, where an endpoint is like a path within the API that you go to do something. So this has the API's tag of APIs, and then it has all the different things you can do. So you can list all the APIs. That's the one we're going to look at in depth. But we could get basic metrics. We could list all the providers, retrieve one version, all these different things. They each have their own page. We have already talked a little bit about what this get means, but I won't have talked about that yet in the current version of the book. Get just is it means that it's basically, you can treat it like a web page. It's one way of accessing APIs, and we're going to talk a lot more about that in a few chapters. But so all of these are get endpoints, and let's look a little bit more in depth at this list all APIs endpoint. Gives a description of what you can do with it. It tells you that if the API exists in multiple versions, preferred one is explicitly marked, and it gives some basic definitions. And then it shows us what a response should look like. So it's going to tell us, we're going to have a whole chapter about how this works, but it's going to say that it's going to send us back some JSON, and that it's that it's got added, preferred, and versions for each API is what it's trying to show us there. We'll look at this in just a second. The other important thing that all these that most API documentation has is some form of example code. Now, this example code tends to be like, this is just the raw, not even curl, which is a thing we'll talk about later, but this is just the website, the URL you can go to see this endpoint and part of the response. But this is a URL. This works just like a web page. And so let's go ahead, and that's not it. This is that page. So I'm going to give it a second to load. This is the entire list of APIs from apis.guru. I want to look at it again a little bit in the browser, and hopefully it will finish. This is something called JSON, which you may or may not be familiar with. This is JavaScript object notation. It's by far the most common format for API data. You can recognize it by the curly braces. That's just basically wrapping the entire object as a curly brace, and then each object inside of that is a curly brace. I am using a browser extension. Let me give you the URL. I'm pasting the URL in the chat. That is what we're looking at. And now, okay, good. I have this browser extension called JSON View browser extension. There are a billion of these that format JSON. And so all that does is it makes JSON collapsible, which is can be really handy for navigating through it and making sense of it. So I do recommend installing something like that in whatever browser you might use. If you use Chrome, you can install that there. But in general, the reason JSON is so popular on the web is it's really great for nested data, which is something you get a lot out of APIs. So here, if we kind of just take a minute to look at it, we can see that there are these objects that are a name of an API, sorry, like oneforge.com or onepassword.com events. And then it tells us when that API was added, what the preferred version is. And then it has this object that is the versions. In the case of the first one, there's just one object inside of that. But if we scroll down a ways, there are some that have several. And so you can get kind of a feel by looking at it like this. Sometimes, though, this might be huge. This might be way too big to really load in your browser. This one's already, we saw it took a while for it to process in my browser. And, searching through here and finding, we can see it's got this category financial. How can I cleanly search for other things that have that category? Well, if it were in R as a data frame, it'd be really easy to do that. So let's go back to the slides. We are going to look at another tree-like structure in a little bit, but we're gonna go a little I'm going light on the format because you're not going to be writing JSON by hand and you're not going to be processing it by hand. I will within the book link to resources about what the format is, but mostly you just need to be able to recognize it and then load it. And for my purposes, you don't need to know every nuance of how it works. So I'm not going to go super deep into it. We're going to talk also about YAML in a little bit and just how to recognize that and what it is. But again, not going to you won't be able to write JSON by hand or parse it by hand because you don't need to.
John, can I ask a clarification question?
Sure.
So looking at these the websites of these JSON files, that is you're emphasizing how long it was to load. Each API, that can't be true. Each JSON file is like everything that you could possibly be requesting.
This particular one is list all APIs in the catalog, and so it
Yeah,
can be super long. And basically, I wouldn't recommend loading them in the browser because it could be something insane.
but
And
each API, each thing that you're trying to hit, unless there's some security, unless there's some authentication, like they're all possible to be enumerated entirely in the browser. Like that's part of the documentation is this whole JSON thing. It's like a database.
yes. So this is actually the API. So we have hit the apis.guru API at that URL that I pasted. And it is like we made an API call. Now that API call is just a list of everything that's in their database. But
so
we
some
actually
of these
made the
are gonna
call.
have like things to fill in. Sorry, not
Right.
variables. And in which case
Yes.
you wouldn't see everything because there's still some processing that happens somewhere else.
Exactly.
Outside.
Yes.
Okay.
So that, yeah,
Okay,
this
that makes more sense.
particular endpoint is just a list everything endpoint.
Yeah.
I guess,
Okay.
I'll make sure I make that a little bit more clear. But we're going to use that in order to kind of learn some basics about how we can process JSON, because you will often, like the kinds of APIs you're hitting from R, kind of the point is to grab data, usually, like some largish collection of data. And so I wanted to find something that is a fairly big nested thing that we can pull into R fairly easily and process. We're not going to really be working on the API part this week. We're more focusing on how to like process the data once you get it in.
I think that makes sense.
See that in just a second.
But you also mentioned that get was a like only one kind of thing. Is that true?
Yes.
Okay. But that's the most common.
Yeah, I am picturing that being like a footnote or a little parenthetical or something that we will talk. Like I think it's chapter 6 or 7 right now is going into all the other types, because we can get a long ways with just get. And the web is get. Like if you load a web page, you are technically making a get API request.
Okay.
So that's what we have started with. And you don't even need to make what feels like an API call. If it is a get request, we can just use this function or this package, JSON Light. JSON Light is one of several packages for parsing JSON, but we're going to stick with JSON Light for a lot of reasons. Number one, it works, and it's used by lots of other packages. If you've used Shiny, you have JSON Light installed on your in your RStudio because Shiny uses JSON Light. Hitter and Hitter2, the API packages that we're going to be using throughout the book, use JSON Light. Plumber uses JSON Light. And in addition, just dozens and dozens of other packages use JSON Light as kind of their way to communicate with other services, because JSON is this really, it's like the standard of the web. So there's a question in the chat about GraphQL, graph query language, which is related to JSON. It's like JSON with holes is what turns it into a query language. So you say, I want something that has this structure from your data, and it can, you tell it pieces. That is potentially a whole other chapter. And so I'm not going to dig into that right now, but yeah, it is strongly related to graph query language, which comes up a lot. All right, so within JSON Light, there's this function from JSON, which I'm showing here. It does some guessing of what you're giving it. So like I'm giving it a string that is a URL, and it looks at that and says, oh, that's a URL, and we'll go and fetch that. You can also give it the literal JSON. So I could like copy and paste the whole giant JSON string into it. You can give it a file path. It does a lot of guessing. And Because of that, when you're programming, you might sometimes want to use, there's read JSON, which specifically is going to read a file or URL, and parse JSON, which specifically expects a string. Those two don't do any like simplification of what comes in from JSON. By default does simplify the results that come in. None of that is going to be super meaningful yet, but we'll come back to this in probably next chapter, or the chapter after next. But just know that there are lots of options. You might see different code telling you to do different things, but for beginners, for beginning from JSON, no arguments other than the thing you're trying to get it to load is perfectly fine and acceptable. This result is gigantic. We just looked at it in the web, or on the web. It has 2,529 items within this list. I guess I could have said it is a list at this point. So from JSON turns it into a list. It has 2,529 items in it. The first 6 of them are here. It is named, and you can see that the items are those pieces that we saw in the browser. There's this function that I just found actually while working through this that I did not know about, but I find very helpful for working with nested data like this. Pluck depth from the purrr package tells you how nested a nested list is. So when we call pluck depth on this all APIs object, it says 10. That means that somewhere in here, at least one place, there is a list that contains a list that contains a list that contains a list down 10 levels. So that tells that kind of is, I just included that to show like this is very nested. It's things wrapped inside of things wrapped inside of things. There's also the str structure function. If we look at just the first 2 elements of this list, the max.level argument to str is a really handy way to look at nested structures like this, because I'm telling it, don't expand this level. Like, yeah. So Rebecca said, I had no idea there was max.level. I just learned about this on Mastodon like a week ago. And I was like, oh my God, this makes all this so much easier to explain. So yes, this is beautiful. And therefore we can see, okay, we've got objects that contain added, preferred, and the versions, which is a list. Another object, added, preferred, versions. So yeah, there it is. It's in list format. Some people are super comfortable working with weird giant nested lists, but chances are, if you're working in R, especially if you've read the new version of the intro chapter and made it this far, that you learned that I am going to be very opinionated about using the tidyverse. It'd be easier to work with this if this were in a data frame. And so that leads us to rectangling data. So rectangling is converting hierarchical data like this nested list into a data frame or other rectangular structure. Rectangular data is nice because then you can use the tidyverse to wrangle it. You can filter and you can mutate and you can do all those things that you may have seen in other places. There is a whole chapter about rectangling data in the 2nd edition of R4DS. It's chapter 23, hierarchical data. I am not requiring that you have read that because I actually kind of disagree with some of how they say to do things in there, especially for named lists. There's a function that we're going to use that I think makes things a little bit easier to work with. But the other thing that I want to point out is that when you are working with hierarchical data and trying to rectangle things and trying to dig in, you may have to do some like trial and error when you're trying to figure out, do I want to make this longer or wider? Which functions are going to make the most sense here? Oh, oops, I lost some names. I've got to go back and fix that. Don't feel like you're doing something wrong if you have to do a little bit of work with this. And so the other thing that means is often, if you're working with giant data, you may want to just like subset the data, take only the first couple elements of the list, work through it, and then expand out to everything else because things can get really hairy. Actually, I'm not going to go over the other bullet that I had in my notes. All right, yeah, because we're going to talk about it later. So we have that giant list. I'm going to start with a function that is I find super helpful. Actually, not mentioned anywhere in R4DS. I did a search earlier today. I don't know if, I mean, it's not like listed as superseded or anything, but it is Tibble in frame. I love this function for working with lists. You can do like Tibble data equals all APIs, and it's almost equivalent, but this like handles lists and vectors, but especially named lists really well, because what it's going to do is it is going to take the name of all the elements of the list, like that one column, and then the values, the things that are inside of those objects, and make it in another column. So if we look at what this says at this point, I've got to yell at my dog, so just so we told it, all right, I want the name column to be named API name. So that's what this is. And then value is going to be everything else. I didn't get, you can give value a specific name, but often you will not, because we're going to destroy this column. We're going to pivot this out. And so it doesn't matter what it's named. Let's see. And so, yes, in frame plus pivot wider, that is like my combo, or sorry, unnest wider actually, is something that I do quite a lot. In API packages, I sometimes have just I make a wrapper function, like n_un that enframes and unnests all in one step, because it's something you're going to want to do all the time. But so what we have to do is we have to figure out whether those blocks in values are blocks of results, like a collection of results, and thus should be unnested longer into rows, or whether they are results about that one piece of data and should be expanded into columns. I'm curious to see. Yeah, so in frame, actually, like there's not that much complex in here, but there's a lot of checking. It works for a lot of things. I don't want to go into all the details about that quite yet, but it's relatively small. I need to make sure that that's a long answer. 1 second. Anyway, sorry about that. That is curious. I will have to dig into this fix me, but and I don't have an answer right now for you, Jim, but like I know JavaScript does pretty well with them, because like that's what the format comes from. Other things, I'm not entirely certain how they deal with it. But all right, so I'm sorry, but we were on this where we've got this in framed data, and we have one row for each of the names, and then within that row we have this value. In this case, we looked at the data, we were able to see it ahead of time, and we could see that these, like each of these named lists is pieces of information about this one API. But I'm going to pretend that we don't know, because sometimes you're not able to load the data up in a web page and look at it. You're not able to really see what's going on clearly when you do the exploration. I'm going to do a little bit of exploration of what is that object, and how can we kind of figure out whether we want to go longer or wider. So again, you want to go wider if it's multiple variables within that value. So if those three pieces are different variables for that one row, you want to go longer if it's multiple observations. So like different values, or different, different rows for that one thing. So if we look at it, we can see that all of them are length 3. That is something I often like to check. Oh, and also there is the function unnest auto within tidyr that can be useful to give you like clues, but I wouldn't use it anywhere. Like use it while you're doing exploration, that can be okay. But it tells you, okay, now replace this with unnest wider or unnest longer. And I think it's useful to know kind of why it's making the guess. So I still usually like to kind of explore the data myself a little bit and make sure I agree with it, basically. All right, so they all, like every single one of those values, if we look back here, you know, we can see the first 10, but it turns out all 2,529 of them have length 3. That's a sign that either it's a batch size of 3 or there are 3 variables that are for all of them. If we look at what are the names of those 3, oh, they're all added, preferred, and version. So that sounds like it is columns. And so, and then just if I look at the first value and the 11th value, you know, just 2 random values, they have the same names is what I was trying to see there. And so that tells me, okay, yeah, we want to, oh, and sorry, if we also look at the str, again, max level 2, we can see added, preferred, and versions, that they're all the same. They are the same type of data. And so we want to do columns here. Sorry, and it's 3 different types of data per block, and each block is the same of those 3 types of data. All of that together says, yeah, we want to go wider. I am now curious, like, was that too fast or too slow or neither? Is this something valuable to kind of go through, or would you rather I just do unnest auto and accept it? Are we good going through? And I guess I'll get feedback about that too when we're done. I think it's worthwhile to really dig in and make sure you understand, okay, yeah, that makes sense. Let's go wider. And so if we do that, we can use tidyr unnest wider. This function is a very useful function for expanding things out to get more columns. And when we do that, we take, so that value column has now become added, preferred, and versions. You might be tempted if you're just like, if you've seen some other code or different use cases for unnest, to just use unnest. Yeah, that's a good point. There are nice diagrams of what unnest does, so it's probably worth going into that before we do all this to kind of talk about what unnest, you know, what nesting and unnesting means. That's a good call. I will add that in. But yeah, we went wider and we got added, preferred, and versions. There is a function unnest, which feels like maybe, oh, it's going to like automatically figure it out for me. But what that actually does is it goes wider and longer. And so if you have a Tibble within your column, works great. For anything else, it's going to just destroy your data. It may just destroy your data. So I really recommend just really knowing what you're doing, go through, understand the data, and go either wider or longer back and forth. Unless you know that unnest works, which we will see a case of later. Yeah, so I think that's a good call. I think I probably want to show unnest and unnest longer on this and why that's a bad idea. That's a good call. I'll add that into the slides because it makes it clear why you need to go through here. And yes, it does kind of take some practice to do these. And that's part of what, like, I want to give you something that you can grab and play with and just really slowly walk through it, because this is like a big piece of working with APIs is you're getting back this JSON data, and it's these weird nested structures that you may have never worked with before or only worked with a little bit. And so it's really useful to do this a bit and learn how to, you know, make things nice to work with. All right, so we have API name, added, and preferred. This is the preferred version, the docs said. This is when the API was added, which we don't particularly care about right now. And then, okay, versions. It's another named list. What's going on there? So let's unnest that and figure out if we want to go wider or longer. We have that versions column. Again, I like to look at this lengths unique. Oh, I meant to go over that before. Not everyone knows about the lengths function, which is like the big brother of the length function. It takes a list and tells you the length of every element in that list. I had personally rewritten this with like apply style functions or per 1,000 times before learning, oh, there's a function in base R that just tells you the length of every element of the list. It's really useful for things like this of seeing, what is the variability in those objects within the list? Or let's find the elements of the list that are length 0. So the empty ones, things like that. That's just kind of an aside, but that's what that lengths is about. And we can see that, it's all over the place. They have all kinds of different lengths. That's interesting. Let's dig a little deeper to see if we can figure out what that means. If we look at just the first 10 rows, it's all ones, and then number 10 is a 4. If I hadn't gotten any variability, I would have increased this number. So just, dig through until you can find some rows that are different. And when we do that, if we look at, the first one, so one of the ones that's length 1, look at the names, and it is 0.0.1. Okay. If we look at the fourth one, it's totally different. Like it's 3, 4, 5, and 6 are the names. And so this is telling me that these are not columns. These are not like variables about this data. These are all like separate pieces of data. Each one of these, the name also gives us a little bit of a tip. These are, and if we look at number 10, it has 3, which is a list of 7, and 4, which is a list of 7, and 5, which is a list of 7, and 6, which is a list of 7. And if we did the same thing for that 0.0.1, it's also a list of 7. These are all like separate pieces of data, separate rows, separate observations within this row. So if we go ahead and pivot this unnest this, again, in a future version, I will show what happens if you do it wrong. But if we unnest this longer, we do care about those names. So, we had this 0.0.1, that's a version name, 3, 4, 5, 6, those are version names or version numbers. And so we want to keep those. And this argument within unnest longer, indices 2, is how you say, I want a new column called version or version number or whatever you might want to call it, that contains those names. That's all that indices 2 piece is doing. And then I probably should stop and show what the result is at this point, but I'm wrapping this up into also filtering to only keep the one where that preferred column is the version, because we don't care about all the other versions. We just want the one they actually want you to use. And then I'm also going to get rid of some extra columns because it makes our data messy. So if we look at what we have produced at this point, we have each API name. Sorry, I realized I've been pointing at my notes and not at the slides, but sorry about that. So API name, and then we have that version column that we just created, which is the same as the preferred column. And then within that, there's still a versions column, which is a named list, and there's 7, 7, 7, 7, 8 on number 7. That's interesting, but it's looking like it's something consistent. So we'll do one more. Should we take that column and make it wider or longer? And just to be clear, like we could stop, like depending what we're trying to do, this might be enough. We might not need to dig deeper, but most of the time you're going to want to try to, as much as possible, just get a nice clean table that you can work with, Tibble. So let's go ahead and unnest this thing wider or longer. Let's find out. If we look at it again, do that lengths unique. It's 7 or 8. Okay, that is interesting. If we look at that row 7, the names of that one versus row 1, it just has one extra name. Otherwise, the other 7 names were the same. That's what this is telling us. And therefore, that looks to me like it's going to be different variables for that row. And so we can take that and unnest it wider. And I'm going to show it or look at that on the next page, but and again, it's just because it didn't fit nicely here. Did that make sense? Did you follow why I unnested wider? Or did anyone not follow, I guess is the better question, or have questions about it? And again, feel free to like ping me on Slack if you don't want to speak up right now or anything like that. All right. I do want, so I'm going to step back a sec and just show, like, we could have done this all as a pipe. So I just want to show that pipe real quick. We took the list that we downloaded with JSON, we unframed it, gave the name to the names from the list, we unnested it wider, then we unnested it longer and kept the version as, or the names of the version as a column called version. We filtered to only keep the preferred version, and then we got rid of the added field and the preferred field, those two columns. The added because it would cause a little bit of confusion in a minute, and the preferred because it's duplicated data with version. And then we unnested wider that versions column, and that's where we ended up with this Tibble, where we've got the API name, the version, the date that this API version was added, and then this info column, which is still a list, and when this one was updated, and a couple other columns, Swagger URL, Swagger YAML URL, Open API version, link, and external docs. Talk about those in a second. I'm not going to go through all of the info column, partly because of time in this presentation. In the book, I probably will. This is just another one that we need to look at, but this one is curious because there are like 60 names inside of this info column, and not everything has all 60 of them, but there is a lot of overlap. And so it's one where this would probably be a good one to show, actually, going longer and wider and seeing why, oh, longer was a bad idea. Actually, longer would break because they're not all the same type of content. But the thing I want to show right now is within this info, back on in here, oops, within info, there was X APIs Guru categories. I want to grab that field out, and I don't actually want all the contact info and like the logo, all these different things for what we're looking at right now. So I'm just going to pull out one piece of that column, partly again to show you another technique for dealing with nested data. Sometimes you don't want to just spread out the whole thing. You just want to pull one piece out. So let's do that. We can do that using this function hoist from tidyr. So instead of unnesting, we're just going to grab one thing from that info column. You tell it which column you want, and you say the one thing I want is I want a new column called categories, and I want to use the object named X APIs Guru categories to create that. And then this next step, there are several ways we could do this, but one way to do it is to then look at it row-wise and filter for open data. And I'm just choosing a random type of value. So like, you know, we could have done financial, we could have done security, we could have done all kinds of different things, but I did open data because I'm trying to find things that we can use without having to have a login to them for future pieces of the book. And we can see that there are 318 APIs on apis.guru that are tagged as open data. And so we could then explore these more in depth, maybe look at what other categories there are within them, look at other things from the info, but that lets us load or get a subset to look at. So I just want to pause for a minute there. Did all that, like, could you follow? Did that make sense? Was there anything that you wish I had done more about, or maybe less? All right. All right. So within this table, you know, we saw that we have something Swagger URL, and then there's also the Swagger YAML URL. Swagger URL, if we've looked at these are all links to .json files. So these are the JSON, something JSON for each one of these things. And I guess I can load up this. So there's this apis.guru, v2 specs, oneforge.com, 001, swagger.json. And then there's this also swagger.yaml. YAML is another data format. It is technically a superset of JSON, which means you could just change any .json file to .yaml, and things that parse YAML should be able to parse it. But you can also, it also has other things about it. So if we look at, this is the YAML version of the APIs.guru spec. The main thing is it's made to be a little bit more human readable. And so instead of having, instead of having everything on my browser is reacting slowly, as objects in a comma separated list within this other object, and then that they break down, it just makes each one's a row. That's the main difference. It also, you can do some like commenting within YAML and different things like that, but it's just another format. For the most part, we don't care which one we use. Oh, sorry. And the other thing about YAML that might look a little bit familiar is our markdown headers and package descriptions are within our YAML. And so that's formats that you may have seen before. We mostly don't care what format things are in, because we're going to be using functions to parse them into lists either way. But it's good to know that both exist, and you can fairly quickly spot the difference if the file name doesn't give it away. They don't all have to be named .yaml or .json. But you can spot the difference because this doesn't have commas on the ends of the lines. It's just a new row for each piece of data, and it doesn't have a curly brace, whereas JSON is always, or big JSON objects like this are going to start with a curly brace and end with a curly brace. All right. And then the other question you might have is, why Swagger? Why is it Swagger URL and Swagger YAML URL? Swagger is actually the old name of a standard for API specifications. The new name is now Open API specification. A company produced this for their own API, and they were using it internally, and then they released the specification, and a company bought the specification and made it open source, and then built their whole business around people using that specification. It was a clever business model, I guess. So Swagger was technically Open API version 2.0, and then there is now an Open API 3.0 and 3.1 and a few other minor versions within there, and they're working on 4.0. But in general, if someone uses Swagger or Open API, our lives are going to be easier, because we're going to see that it's got this nice machine readable format that we can work with. I realized I'm still sitting on that page. Oops. But not everyone does. Try to get back to my slides. All right. Okay. And I think we'll go ahead and get started in it, but I'm not going to make it all the way through everything about the definitions. Maybe only a few slides. We'll see. All right. So I realized that I called this API definitions. It should have been descriptions. API description. So, okay. Technically, the Open API specification is the name of the standard, and then each thing has an API definition, but you will see these, or sorry, has a description. You'll see these terms, specification, description, and definition, used interchangeably. It doesn't really matter, but I'm going to try to clean up my wording and use it a little bit more consistently. So these files are the description of the API. It is like, when done properly, it literally tells you everything about how the API works. It tells you how authentication works. It tells you the URLs that you need to go to. It tells you what parameters you need and what format they need. And it tells you what to expect in returns. And so we can use that to like automatically format the returns. We can use that to figure out what data we need to send in. They're really helpful when they exist. Technically, the higher the version number, like the more clean that version is. So Open API 3 or 3.1 is going to be easier to work with than Swagger, but a lot of companies still use Swagger, so we'll talk about that a bit in the book. And even with the newer versions, there are still things that are going to be confusing that we'll go through a little bit. For example, we're going to see that there's like a security section in some of them, but then there's also this security schemas, some subsection, and there can be security within different places. And so just understanding why that is can be really confusing. And then the kind of most important thing is these are a standard, not a law. And so you will often find things that are wrong in people's API descriptions. But you can, if you know what it's supposed to be, you can usually kind of make sense of it. And so I'm going to go ahead and dive into a couple of these, and then we'll see how far we get. All right, so I have links in the notes to 4 of these. I'm going to go through at least the first 2, and I'm almost definitely not going to go through the 4th one. We'll see if we make it to the 3rd one. And go through meaning I'm just going to kind of quickly look at them. So we were, this is the YAML version. Again, I have that nice browser plugin, so I find the JSON version a little bit easier to work with because I can collapse everything. This is the Let me grab happy link address. So this is the JSON view of the apis.guru description. So the useful, or this is the full definition of this API. So it tells us, okay, we're using OpenAPI version 3. It tells us where the server is that we need to hit in order to access it. It has this info section that is like contact information. If we look back at the this page, all of this is basically the info section of this description. Within that info section, we also have like the categories that they added. You will see these X names a lot within these. X just means it's an extension. And then if you put X in front of it, you're allowed to put pretty much anything. And so they have an extension, which is their personal categories that they have added. For the most part, info is not super like useful info as far as machine readable pieces of it. But the really cool piece is down here in paths. So paths is the full definition of what can you do at each point. This is what the docs are built from. And sometimes you will find things that are in the API description that get edited out of the docs or things like that, but it's what's really behind the API. And so it's a nice way to come down and see everything. But it would be even nicer, if we could load it in automatically. And so we'll look at that in just a second. And then I just wanted to go through the other piece. An important piece is this components part. Components is for reusable information. And so in this one, it happens to have these API and provider parameters that are referenced in a whole bunch of different paths. It's like if you're going to reuse the same argument, it defines it once. That's a little bit annoying because if you're looking at one specific path, if we load yes. So it says that we have doesn't have. Sorry, there we go. So in this provider's API JSON. So in this particular path, it just says ref components parameters provider and ref components parameters API. If you're trying to read this particular path and understand it, having those references can be confusing as a human. It's convenient as a computer, but confusing as a human. We'll come back to that in just a moment. And let's see, is there any other piece? There's nothing else we care about in that one.
I asked a question about the level below paths. There's like a .json. Is that actually a file that's somewhere listed?
No, that is the actual path. So this list.json is what we loaded up above. And it just happens to be that in the apis.guru API, the names of their paths have .json in them because they're not really APIs, they're just files in a lot of cases. So that's just it. That is you can go to api.guru list.apis.guru/v2/list.json, and that is that thing we were looking at earlier.
Oh, okay, so it's just the
Does that make
name
sense?
of the endpoint of
Yes.
that endpoint. Okay.
And so you take server, that's the base, and then you add on list.json, and that is this particular endpoint.
Okay.
I wanted to go to one that's a little bit more normal. So that's this FEC one that I've been talking about. Some quick things to notice there. And, you know, if you have to go, that's fine, but I'm going to try to get through a little bit more here. This one has some idiosyncrasies that you should watch out for. That it for the URL, it just says /v1. And that's because by default, servers can, like, it assumes that it's going to be at the same place where you found the doc. And this doc was at here. It's at api.openfec.gov/swagger. And so instead of /swagger, it's saying go to /v1. I think most of them don't, like, they use the full URL instead of doing that variable form, but that's something you need to watch out for when you're reading these docs. And then this one has security defined. This top level security section is telling you that unless I say otherwise, all of these security things are options. We'll have a whole separate chapter talking about this, but this is just an example. But it's also an example of some of the confusion, because it's saying, okay, you can use the API key header auth security, or you can use API key query auth or API key. If we go down into components, there's a security schemes section. It's like, okay, there's security and security schemes. Well, security schemes is what that's referencing. And it's this is a mistake, because they have API query auth and API key, and they're exactly the same thing. And you know, they shouldn't have done that. But this is the case where you got to watch out for developers, because they can screw things up. And in the case of FEC, they actually doubly screwed it up, but it's going to make our lives a little bit easier, actually. That they also define that within the paths that you can use an API key. And it tells you that the default is demo key. So they defined security 3 ways that are all the same way. Most of the time that doesn't happen, but that is something we'll learn to watch out for. And we're going to talk about that more in some coming chapters. But again, yeah, it's got, like, all of the paths are defined, and it's got everything about those paths and whether they're get or the other methods that we're going to talk about later, what the parameters are, different things like that. And then just I wanted to quickly show that this is the YouTube one, which, you know, is relevant to a couple of us here. It has all the paths, but it is purely, like, everything in it is these refs to components parameters, or I think down in our, if we looked at responses, yeah, responses are going to be components, schemas, abuse report. It's like everything is just references. And so it's really hard to do anything with that. And that's where we're going to quickly go into how to read an API spec. So I am using YAML here. There's this package called YAML. Surprisingly enough, that is for reading YAML files. And it has a function read YAML. It's pretty much like from JSON. I am using it because it works a little bit better with the Tibble package that we're going to talk about in a little bit. But you don't, like, you know, it's the same thing basically until you start doing some weird things to make your notes look better. But yeah, so you can read that in, and it works just like JSON, or like the JSON Light, where it's going to create a list. In this case, the list has all those pieces of the YouTube spec. So it's got the Open API version, servers section, the info section, external docs, tags, paths, and components. But if we actually tried, if we looked at this, you know, this is still just a list. It's a nested list. We haven't gotten into any Tibblification yet. And that's where I'm going to dive so much more deeply into this package, but I wanted to get everyone introduced to the package Tibblify. this package Tiblify, it has its main function is Tiblify. So you just Tiblify. And you give it a list, a nested list. I'm going to cut down to just the paths part of that nested list. But if you look at it, it like automatically created a Tibble out of that. I'm glimpsing because I wanted to be able to see that it created a nested Tibble that we could then go through and unnest. But again, all of this stuff was references, so that's not great. Okay, if we look at like the first parameters piece of that Tibble, it's saying, okay, parameters are all references to this other thing. So, you know, that might be disheartening, but it also has a function, parse open API spec. And this, we are actually looking at the dev version because I am trying to push him to get this through onto the prod version. This function does exist in prod, but it's not done. It doesn't have all the pieces that we're going to look at here. But this function is awesome. So you give this just the full spec, and it creates a Tibble of the endpoints, the paths, and it does all the expansion. It reads all those components pieces, and it figures out where everything is. It puts everything into this nested operations column. And I want to point out that like captions, or sorry, captions here, v3 captions has 4 different operations. Because then we can use just unnest at this point because we have this nested, these Tibbles. And what unnest is going to do is take those Tibbles and expand them out into columns and rows. And so caption became these 4 rows that it had a delete, a get, a post, and a put. It kind of looks like it's that one too, but that's a different one that just starts with the same beginning. And so now we've got like this Tibble that is all of the paths of the entire API. We're going to be playing with this over the next several chapters because this Tibble is basically telling us how to access the API. But I also want to quickly go through, like this Tibble has endpoint, that means path, that means place you can go in the API, has operation, also known as method. We're going to talk about these a lot in a later chapter, but for now, we're just going to be focusing in on get operations. It can have a summary. Summary is supposed to be like a 1-sentence description of the of that particular operation. YouTube doesn't use those. Some of the other ones do. Can also have a description. YouTube tends to make these the 1-sentence version. But the nice thing is, or a good thing to know is descriptions can have markdown in them. So you can, you know, if you're trying to make documentation, let's say for a package, those are very helpful to have. They also have this operation ID, which is a unique name for not just that endpoint, but the endpoint plus the operation that is meant to look like code, and it's meant to be used as a function name. And so the spec is like asking you to use these programmatically. Has tags that we're not going to really dive into a lot in here, but you know, that's how like the documentation gets organized. It's categories. And then it has fields for the parameters. So all of the parameters of that endpoint there's a Tibble that is all the parameters. And then it has some other fields that we're going to talk about in some later chapters. And I'll see you, Jim. I'm going to try to get through this last little bit because the whole point here is that these are the next few chapters. Well, not deprecated is just, is this endpoint deprecated? When you're working with this, I would highly recommend it just filtering for not deprecated because you want only the ones that actually still work. But yeah, so parameters, quest body, that's something we aren't going to get into for several chapters, but it also gives you information about the responses. That we're going to have a whole chapter about that because it tells you what does the response look like, and we can use this with Tibble to auto format our responses, or sorry, with Tiblify. And then it also has this global parameters, which is like parameters, but the entire endpoint can have parameters. And so Tiblify does a nice job of repeating those for us. So we don't have to keep going up and saying, oh, all of these have this parameter. Yeah, so like I said, we're going to be, Yeah,
Oh,
we're going to be
sorry.
digging into this Tibble over the next. We're going to take a break from it at one point to go into security, but other than that, we're going to be digging into this Tibble because this is how you can explore the endpoints and find all kinds of cool things and kind of have the documentation in R, and so you can search it and find things. So I was gonna say, go ahead, Kevin. Did you have something else?
Yeah, just a question. So does this, I missed this, does this also undo the referencing stuff to,
Yes.
it does?
And
Oh,
so,
wow.
yeah, so all the references are in here now. So these parameters, if we expanded this out, it is all of the parameters of this call, all their definitions, everything that is known about them. So it does have a lot of duplicated data, but you know, for the most part, you probably don't care if you're trying to learn how this one endpoint works. You don't want to have to reference the reference or the single component over and over. And so, like I said, we'll dig into this a lot more in the next coming chapters. But I do have a survey that I will obviously put into the channel, but also I'm going to put it in the chat, and it's also available in the notes that I would like everyone to fill out. So, and that gets us to the end. And I wanted to get there. I know, so it's a little long, and that is, I have found that almost every book club can do a chapter a week or a chapter every 2 weeks. Like it's one or they line up really well that way. And therefore I kind of want to use the book clubs. Like if we can't do a chapter in a week, then the chapter's too long. And so that is something interesting from this. I know there were some pause points and whatever, but it does seem like maybe this one needs some information pulled into a separate chapter. But yeah, I after attacking this, I like this setup a lot better because this gives us a story. It feels like and it gives us a thing. Like you don't have to learn all the complicated things of Hitter 2. Because you're still gonna, like, even with Hitter 2, you're gonna have to do all that unnesting stuff. And so let's learn that without having to learn a whole new package other than one function from JSON Light. All right. So yeah, I'm gonna let you go because I need to run as well. But I will post the survey in the channel, and I'll try to get this up as soon as possible since a lot of people didn't see the end. But thank you very much.
Awesome. Thanks, John. See you next week.
You're welcome. See ya.